Finally today, agricultural technology has grown by leaps and bounds over the last couple of decades. However, just because progress is made doesn't mean we stop looking for new ways to innovate. UNL Associate Professor of Advanced Machinery Systems, Santosh Pitla, was kind enough to give us a behind-the-scenes look at how he and his students are creating an autonomous tractor that implements ground robotics. This technology could eventually allow producers to better meet the growing global demand for food.
My research is in the area of agricultural robotics and machine systems automation. So our goal is to build the next generation of machine systems that are helpful to produce food, fiber, and fuel in the most efficient way possible. With that in mind, we are developing smart robotic platforms that can go into the field and analyze the cropping conditions and then apply fertilizers, chemicals in the most efficient way possible. So if we can save on the crop inputs, when you are very precise in how much crop inputs you're applying, so that will increase the profitability of an operation, which means you're applying less, but you're getting more yields because you're saving on crop inputs. And we have to be doing all this with keeping environment in mind, right? So we got to be least, we got to have the least negative impact on the environment, and being precise with the robots can definitely help with that. All right, so what we have here is a 60 horsepower robotic platform that is field usable. And this robotic platform, our goal is to make it very practical so that farmers and producers can actually use it in their fields. And since this is 60 horsepower, we can use it for multiple purposes. So you could do sensing of the crop to know what is the status of the crop in the field. And you can also do a 2-row unit planting operation. And then we can also do spraying operations. So this is a really modular multi-purpose platform. And some of the unique features of this robot is that this has a 4-wheel steering. So not just 4-wheel drive, we have hydraulic motors driving all the 4 wheels, but we also have 4-wheel steering so that you can do different steering modes, like an Ackerman steering, which is very typical, like a car that has Ackerman steering. But you can also do crab steering and articulated steering. So you have very unique steering opportunities with the goal of improving the field efficiency. So with the goal of getting more useful time in the field. So this since this is 60 horsepower, so we are using internal combustion engine and a hydrostatic transmission that involves hydraulic pumps and hydraulic motors. This has a communication system called CAN bus system that is industry standard that makes it very modular. So you can add and remove multiple computer modules on this robot so that we can use it for various operations. And on the front, since this is a driverless machine, there is no operator, so we can use a remote in manual mode, but we can also put our computer and give it a GPS path. So using a GPS, it is going to follow those waypoints or path that we provided, and it is going to work in automatic mode. So we call this supervised autonomy because we still need to take this robot from one field to another field. So that's why we call it supervised autonomy. And what you're seeing here is a obstacle sensing module. So since there is no operator on this, so it has to know when there is an obstacle in front of it, it needs to react and stop. So this robot can, if there is an obstacle in front of it, it will stop at a safe distance. So it doesn't damage itself and also doesn't damage the object that is seeing in front of it. So, agriculture today is very different from what it was many years ago. So when we are training students in the agriculture engineering and mechanized systems management area, we are talking about a systems approach, right? It's not just designing a machine, but it's also about the mechatronic system, the software systems, and how all these technology systems are interacting with the crops, the soil, the land system, and the water bodies. So it's a systems approach that we are trying to engage our students in. So it's always very exciting to see freshman students, especially where they're very interested in learning, whatever learned in their class, the theory, how does it translate to practice, So those are some of the things that I'm very passionate about, is whatever they are learning in the classroom, how can we relate to what's happening in the real world? And these type of lab activities and exercises really allow me to bridge that gap between theory and practice.